In question 3 you're given 4 points and you're asked to plot those points on the coordinate graph that you're given. If you have any grasp at all on coordinate geometry, this question should pose absolutely no problem to you. So all you do is you put A right here at x equals 6 and y is equal to minus 1. B is down here at 12 minus 3. C is at x equals 8 and y is equal to 5. And D is at 2, 7. In part B, you have to describe two methods for showing that 4 points form a parallelogram. Well, first of all, what are the properties of parallelograms? Firstly, we know that opposite sides are equal in length, so this side here has the same length as this side. And this side, on the right, has the same length as this side on the left. Secondly, opposite sides are parallel, so this top side here is parallel to the bottom side, and the right side is parallel to the left side. Thirdly, opposite angles are equal in measure, so this angle in the top left is equal in measure to this angle at the bottom right, and this angle in the top right is equal in measure to this angle in the bottom left. Lastly, the diagonals of a parallelogram bisect each other, so this is one diagonal and there's the other diagonal there. And the point where they meet then is the midpoint of each of those lines. In other words, this length from one corner to the center is equal to the length from the center out to the other corner, and the same with this line here. This length from this corner to the center is equal to the length from the center to the opposite corner. We can use any of these properties then to determine whether or not a given quadrilateral structure is a parallelogram. First of all, let's check out the opposite sides are equal in length. Well, to determine whether they're equal in length, you have to find out what the lengths of each of those sides are. So find the lengths of each of these 4 sides, and you can just use the distance formula for that. Remember, you're being asked to show using coordinate geometry techniques, so this is the kind of formula you would use as opposed to a ruler or something like that. So if these two sides, these opposite sides, are equal, and also the other two opposite sides have to be equal. If only one set of opposite sides is equal, you end up with a rhombus, I think. So if both of these conditions are true, you get a parallelogram. If you wanted to use this property that opposite sides are parallel, well, to prove that two sides are parallel, you have to find what their slopes are. So using the coordinate geometry techniques, again, you just use the slope formula. You can figure it out that way. If you want to use that the opposite angles are equal in measure, again, you can just use things like cosine rules and sine rules, but in that case you're going to need to know the lengths of the sides anyway, and by that stage you might as well have just used method 1. So I'm going to use this fourth property here, that the diagonals bisect each other. To use that property, that the diagonals bisect each other, I have to look back at my parallelogram here. Now if this length here is the same as this length, and this length is the same as this length, then that means that the midpoints of both of those lines is the same. Now notice that I'm not saying that this length here is equal to this length. I'm just saying that the midpoint of the two lines is exactly in the same place. So you can find that using the midpoint formula, which is just x1 plus x2 over 2. It's just finding the average of the two x coordinates, and y1 plus y2 over 2, again finding the average of the y coordinates. So you have to do this for each of those two diagonals, and then if the two midpoints are equal, you get a parallelogram. In part C, you have to use one of your methods to show that ABCD is a parallelogram, and you were given the coordinates of each of these at the start of the question, and here they are. I put them in this particular order for the reason I'll show you in a minute. So I'm going to use this one here, method 2, that used the midpoint formula, just because I know in advance that this is going to be shorter than the other methods. It's only going to take 2 equations, whereas if I wanted to do the distance, I would have to find the length of 4 lines. If I wanted to use the opposite sides of parallel, I would need to know the slopes of 4 lines. With this one I only need to know the midpoint of 2 lines, so it's just a little bit quicker, and it's no harm to save a few minutes in the exam this way. So the midpoint of AC then is given by the x-coordinate of A plus the x-coordinate of C, taking them from here, and this is why I have A and C together. So I add those together, divide by 2, then take the -1 from A and the +5 from C, divide that by 2, and I get 7, 2. To find the midpoint of BD, again I take the x-coordinate of B and the x-coordinate of D, divide them by 2 after I add them together. Then take the y-coordinate of B, add it to the y-coordinate of D, and divide it by 2, and I get 7, 2. Now since these two are the same, in other words these two line segments have the same midpoint, that means that ABCD is a parallelogram.